Alright guys, it's Final Exam Guy. Welcome back to the final and third installation of the Engineering Economics Management final exam walkthrough. We just got a couple more questions to go before you're all set. We'll start with number 49. The cost of a medium-sized lathe in 2006 was $18,450. The industrial equipment price index in 2006 was 125. If the current price index is 174, the estimated cost of a similar sized lathe is close to. Alright, so we got two indexes, a current one and an old one, and we have an old price. We just need to find the new price. So it's kind of like just a proportion, setting it up. So in the past, let's start with writing past. Index is 125 and price 18,450. Today, the index is 174 and the price is being asked for. So you can just see it's just setting up like a proportion. So it's usually done how you do it is new index over old is equal to new price over old price. The index is kind of like a benchmark, the compensating for like inflation and stuff like that from the past to the present. So let's just go ahead and plug in the values that we know. So 174 is the new one over 125 is equal to, we'll call it X over 18,450. In doing cross multiplying and dividing, you end up getting X is equal to 25682.4. This corresponds to answer B. Alright, so the next question might look like the previous one, but there's a difference here. At the beginning of 2004, your company purchased 15 tons of raw materials for $320,000. In January 13th, the same 15 tons of raw materials costed $385,000. The average inflation over this period is close to. Alright, so we're going to write down our givens. 15 tons costed us $320,000, and that was in 2004. 15 tons in 2013. Something's lagging here. Was 385 in 2013, and the difference in years is 9. It's asking for the inflation rate. So the formula for this is the future. So today's value is equal to the old value multiplied by the factor that accounts for inflation. So that's usually 1 plus the inflation rate, we'll call it X, to the power of the years that have gone by, 9. So we can just call this whole term X, plug in our values. Today's value is 385. 1, 2, 3. 320. 1, 2, 3. X to the power of 9. Let's just solve this, show you guys. So bringing over the 320,000 dividing both sides by it gives us 12.03. Equals X to the power of 9. You have to take the ninth root of both sides. So I just like to write X is equal to, that's equivalent to writing X is equal to 12.03 to the power of 1 by 9. So you get an actual value of 1.0207. And if you remember, I said that the bracket value over here is of the form 1 plus x. So this can be written over here as 1 plus 0.0207. You'll always get a 1 here usually in these calculations, and the terms after will be your inflation rate. So converting this to percent, you get 2.07%. This corresponds closest to option D. Alright, welcome back. I took a short break, but I'm back. This is the actual last question, guys. We've made it this far. Let's give it a read. A mechanical engineer has decided to introduce automated, for some reason is blanked out, handling equipment for a production line. She must choose between two alternatives, building the equipment or buying the equipment off the shelf. Each alternative has a different service life and a different set of costs. So alternative 1 is build to custom automated materials handling equipment. So we have all the values here. And alternative 2 is buy off the shelf, these values, and then the MAR is 9%. The important thing to note about this problem is they have different service lives, guys. So what we want to do is we want to make a present worth analysis and see which one is higher. But it's important to note, when you're doing a present worth analysis, the service lives have to be done on equal timelines. So if I go and calculate the present worth of alternative 1, and then I calculate the one of 15 years, and I compare them, that's not a valid comparison. You need to have them on a least common multiple. That's what they call it. If you decide to evaluate this using annual worth instead of present worth, you don't have to get common service lives. You can evaluate the annual worth of alternative 1 as is, and you can evaluate alternative 2 as is. But we're going to do present worth to show you how it works, because that's when they give you a problem like this, they usually intend for you to use present worth to show that you have the skills to use least common multiple. So you can see that the least common multiple between... Alright guys, to get these each alternative on the same timeline, we're going to get the least common multiple of each. So 10 and 15, the least common multiple is 30. You know, that means that we're going to have to repeat this alternative's service life 3 times to get it to 30, and this one has to be repeated twice. So let's start by drawing the alternative 1 cash flow for 30 years, but we'll simplify it so we're not going to have to actually draw 30 arrows. So let's go times 0 time 10, year 20, and year 30. These are the significant points. So we have a first cost of 15,000. And we have labor, which is a payment. Power is a payment. Maintenance is a payment. Taxes and insurance is all payments. Adding these 4 together, we should get 3,700, 57, 6,100, 6,400. That will be paid per year, 6,400. So it's a payment, and it's annual. So let's just say we've gone annually here. Let me fix that. Annual payments. 6,400. And 8. And then we have this, that's it pretty much. We repeat things a couple times. There is no salvage life on this problem, but since we're repeating after every 10 years, we have to add another first cost at the 10th year and the 20th year. So let's say right here we have a $15,000 first cost. At year 10, we're restarting the cycle, so we have to add here another first cost of $15,000. And as well as year 20, there is another $15,000 first cost. So if we had a salvage value at the end of year life, we'd have a salvage value over here, and we'd have a salvage value over here and over here. But that's not the case. So let's calculate the net present worth right here. So net present worth of A. So the first cost of negative 15,000. Let's just do the first costs really quick. So minus the second first cost. Now bring this to the present, P from the future, at our MAR, which is the interest that we're used for this problem, is 9% at year 10, minus the next first cost, 15,000 PF9 at year 20, and then we can do the annuity, so minus 6,400 P by A, 9, and this goes on for 30 years. And that gives us a value of negative 89760. Alright, let's draw the cash flow diagram for alternative B. Oops. Cash flow diagram. And this goes on for 30 years as well, but it's only repeated once. So 0, I'll just go straight to that, 30. First cost of 25,000. Another first cost over here. And that's it. Repeating after 15 years. We got the annuity, so adding all these up here, these are all payments, is 5625. So we got this annuity going on for every year up to 30 years. No questions asked. A equals 5625. So finding the present worth, just a matter of converting everything to the present. So PW of B, negative 25,000, minus the second first cost, brought to the future, to the present, sorry, at 9% and 15 years. And we just have the annuity to deal with, 5625 P by A, 9%, 30 years. Gives us a value of 89,649. Those are the present worths. And the question is asking which alternative is better. In this case, you would pick the alternative with the higher annual worth, and that would be this one right here. So the answer is alternative B. And that, guys, is the final exam. I hope you learned something. I hope that you do good on your exam. I wish you guys all the best. Good luck. Don't stress. Take your time. Enter those numbers properly in the calculator. You make one mistake, you can throw off the whole exam. Alright, that's it. I hope you guys do good. And please subscribe for more final exam videos. And like the video, share it. I want people to succeed. Comment down below if you need any further help with the topic. I can see what I can do. I appreciate it, guys. I'll see you in the future. Take care.